I'm Bob Roswell. Is this too loud? It sounds very loud. Great. And I'm on your VCF board along with Doug and Corey and a bunch of other people, Eric, who's here. I also run a computer museum in Baltimore. So two things inspired me to delve into the history of Tic Tac Toe in computers. The first was several years ago, a gentleman came in and said that he had invented a Tic Tac Toe machine, and one day he would lend it to me. And that was several years ago. It finally happened a year or two ago, not even that long ago, about 8 months ago. And this, as far as I can tell, is the oldest working Tic Tac Toe machine. Another visitor came into the museum and told me about Donald Michie. Michie was a researcher, worked with Alan Turing on the decrypting the Enigma machine. And he did some early work in machine learning. And he built a computer called Menace, sometimes known as the Matchbox Educable Naughts and Crosses. It was made out of matchboxes. I'll explain it in a few minutes. I made a liberal interpretation of it. I did not use matchboxes. It was easier to go to Amazon and order these little parts bins. So anyway, that was the inspiration. We built a little exhibit in a corner of our museum. And since we're out west and our museum is in Baltimore, everyone's welcome to come. We're open whenever you need us to be, business hours and weekends by appointment. That inspired this talk. So who started it all? Charles Babbage. Charles Babbage is often considered to be the father of the modern computer. Doug, you can tell us, you had a working model of the difference engine here for a very long time. So he really conceived of a working computer. He has several books. He wrote quite a bit. In his book, Passages from the Life of a Philosopher, he commenced an examination of a game called Tic Tac Toe. And this was in 1840. But the work on this may have begun a little bit earlier. So I'm sure a lot of you are familiar with the Mechanical Turk. I love this guy's name, Wolfgang von Kempelen. Von Kempelen, oh, I see, my screen isn't keeping up with it. That's why I'm looking over here. What do I do here? Whatever. So he built the Mechanical Turk. The Mechanical Turk was this desktop lectern-looking machine with a mannequin on top of it that played chess. At the time, they hid a human being. It was probably not a politically correct term, but at the time they would have been called a midget, who happened to be a chess grandmaster who was able to manipulate a pantograph to move the pieces. And this thing actually toured for 84 years in Europe and the United States. It's documented that Napoleon, Benjamin Franklin, all played and lost games of chess to the Mechanical Turk. And in 1819, Charles Babbage went, either he paid for it or somebody paid for it, and he lost 2 games of chess to the Mechanical Turk in 1819. This is in his own handwriting. This is a document that's in the Beinecke Library at Yale. I think it says here what the game of tic-tac-toe is played upon a board, and you can read it as well as I can. So he begins work on the difference engine. The difference engine is financed by the British government. The one that is here, I believe, actually worked. Is that right, Doug? The difference engine. The one here worked, but as far as my research is that contemporaneously it never worked. There's a book that I enjoyed reading. It was called The Little Engine That Could Have, because it could have worked, but it didn't. While the difference engine was being constructed. He was also working on his next version that he called the analytic engine and did not have funding for it. So he thought back to the Mechanical Turk and said, what happens if I build a Tic Tac Toe game, much simpler, charge people. He worked out the algorithms between 1840 and 1869, so he kept coming back to this over a 29-year period. There's documentary evidence of him corresponding with Ada Lovelace, who may or may not have had anything to do with his working out of the algorithm to play tic-tac-toe. But alas, he did determine that it would be a distraction and it would probably cost too much and he would never make a return on his investment in actually building a tic-tac-toe machine. So we're going to give him an A for effort and an F for execution. The first documented automaton or machine that I can find that played tic-tac-toe was built by Mr. Frank Freeland. He wrote a paper called an automatic tic-tac-toe machine, slight spelling difference. There's a paper, that's just one of the pages showing the schematic of it. It was displayed and is documented to have worked. It was at the Franklin Institute in the 1878, 1879 era. Apparently, it made its way from the University of Pennsylvania back to, from the Franklin Institute to the University of Pennsylvania, and no one seems to know where it is since then. There are a couple threads out on the internet, and corresponded with Bob Shepard and Tom Fine. That's you? Yeah. Great. Tell us what you know. Stand up.
Okay, I'm not actually building a replica. We're looking at, all I did was look at the documentation for it, the instructions for building it, derive the algorithms from that for the push station, and found a couple of errors in it actually. But I saw no reason for it to work. Everything was fine as far as the equations went. And playing with the idea of building two versions of it. One works with simple mechanical logic, paper logic, and the other one possibly normal operated letters and movements.
So more or less like a digicomp or like...
Exactly like a digicomp too, yeah.
Outstanding, outstanding.
Exactly.
And in the thread, somebody claimed to be Freeland's, what, grandchild? Is that what it said? There was a thread about this that was on one of the forums, and someone makes that claim. So the next person who got quite a bit of attention for building one, and we have video evidence of it working, was this Donald Watts Davies with his noughts and crosses machine. And this is 1949. And now I am going to have to change my view here because I can't start the video without it. From the beginning, what's going on? Okay. Okay. There we go.
Man-made lightning flashes from John infinity. From here have come many of the greatest discoveries in modern science. The fantastic powers of electronics harnessed to the service of man. But even the scientist needs a bit of relaxation. And in his spare time, engineer E.W. Davies built an automatic noughts and crosses machine that thinks for itself. No more lonely evenings for the 24-year-old inventor. His machine follows move for move with even greater skill than a human player. By turn effort, it selects from the 6,045 alternatives the one that always wins.
So, found that to be kind of cool. Obviously, a couple of strange things in the video. The first is that a machine cannot always win at tic-tac-toe. Obviously, if the other player plays properly, it usually ends up in a draw. And then there's quite a bit of debate about how many different tic-tac-toe combinations there are. Oops. So now we're going to go on to the oldest working tic-tac-toe machine that is actually demonstrable. And Noel Elliott is the gentleman who came into our office. He's in his late 80s now, and we cleaned out his storage unit of some interesting items that he had built over the years. This is his tic-tac-toe machine. It weighs 55 pounds. It has relays in it. He started with these selector switches and then hand-built more wafers, so more layers to each selector switch. And it's kind of cool. He was written up in Look magazine in 1950 as a boy genius. There's a picture from the Look magazine article. The binder that I have with it is phenomenal. He worked out every combination of tic-tac-toe and every wire and documented every piece of this build. I've really never seen anything that well documented. And let's see here. So I turn it on. I chose to go in the upper left. The machine went in the center. I went there. And after you turn on several switches, it makes that delightful hum, but it does work. Two prior arts documented. But that doesn't stop AT&T from getting a patent on a electromechanical tic-tac-toe machine. Let's see, page down here. I'm having real trouble here because this is a two-screen setup. Oh, that's on my screen. How do I switch screens here? Drag this over. There we go. Okay, who knows how to do a multiple screen thing? Where did it go? My apologies. Click. Go. Make it large. Here is a patent by Mr. Bill Chrysler, William Chrysler, who was at Bell Labs for years. It's documented that he was really good friends with Dennis Ritchie. And Dennis Ritchie's brother now runs a game company that sells educational games. So he built a tic-tac-toe machine. I have a particular fondness for this machine or one like it. So most of us love our first computer. My first computer experience was in 1964 or 1965 at the New York World's Fair in the AT&T Bell Pavilion. This machine that he invented was displayed, and as a little boy I was able to walk up, wait on a line, and play tic-tac-toe against the computer. The machine was also taken to the Canadian Expo, I think it was in Montreal in 1967. Lots of details on how it works. In the patent, all the schematics are here. And now let me put that screen away if I can figure out how, and get back to this. There's Chrysler with the machine, and it was at the 1964 New York World's Fair. And guess what? It's here at the Computer History Museum. And there is the first patented tic-tac-toe machine. And I would love to get permission to clean this up and turn it on, but Dag and his team were nice enough to get this out of storage. And with your permission, it'll be over in our booth for people to take a look at. So as long as we're at it with great tic-tac-toe machines that are the property here of the Computer History Museum is the Thinker toy computer. So a grad student named Danny Hillis built a machine to play tic-tac-toe. It contains 10,000 Tinker toys and some fishing line. He worked out the programming in Lisp on a PDP-10. Dag says that the one that's here is incredibly fragile. Another one was built and apparently was at the Mall of the Americas. Where's that, in Minnesota someplace? And apparently it may or may not still be a display. Anybody ever seen it? There's pieces in a box. I just love this thing. The idea that it could have worked, or did work. Those of us in computer history are always debating about what is a computer. And the question here is, this machine has gates, if you consider relay to be gates, but it is by no means a general purpose computer. You can't reprogram this to do anything else other than to play tic-tac-toe. The prior machine used some of the switches from a Stroger telephone switch. So here's a picture of the EDSAC. The EDSAC was a general purpose computer, second one built after the ENIAC that was actually delivered, used for multiple things. In 1952, Sandy Douglas programmed it to play naughts and crosses. I was not able to find a video or anything else of it. And at the same time, the Ferranti Mark I, there was an implementation of tic-tac-toe. And I love this. You can buy this book on Amazon. It's called the Tic Tac Tome, and it's a 1,440-page book that plays tic-tac-toe. So I start from the book on one side. If the human goes first, I turn the book upside down, start from the back, and the book goes first. So the way this thing works is I turn to page 0, and I decide where I want to go. And just for taking a couple pictures, I decided I would go in the center first. So I turn to page 5, and on page 5, I see that the book went in the upper left-hand corner. And then I went in the upper right-hand corner, which told me to turn to page 39 of the book. So I went to page 39 of the book, and then the machine went down there. And then I had to block, and away it goes. So it's kind of fun. It's a computer program with nothing other than 1,440 pages of go-to statements. So this was sort of the impetus for the exhibit. This is the Matchbox Educable Naughts and Crosses from 1960. And what's really different about this is Michi was doing some of the real pioneering thinking and work in machine learning. So in this case, although Michi had worked on the bomb, on the machine to decrypt the Enigma, in 1960 he did not have access to a computer. So he built his machine out of 304 matchboxes. So I'm going to try and explain how this works without my usual props. So if we think about tic-tac-toe, the first question is, how many first moves are there? Anyone want to? 9? That's a reasonable argument. Obviously, there's nine places. But I'm going to argue, and you can, that there's really only 3 possible first moves. Everything else is a rotation or a mirror image. So the 3 possible first moves are a corner. They're all the same because I can rotate it. A side where I have the red bead, or the center, which is a white bead. Everyone good with that there's only 3? So at state 0, in the first position, the machine is going to move first. He set it up so that there were 8 green beads, 8 red beads, and 8 white beads. So I shut my eyes, I go into the drawer, I randomly pick out a place, and that's the machine's first move. So completely random. I put the X wherever it comes out. I then, as the human player, move wherever I want to. I then look for the drawer that has that position on it. Again, to simplify this, I have to do the rotations and the mirror images myself. I go into the next drawer, I pick out a bead, the machine moves, I move, and that continues until there's either a win, a draw, or a loss. So in the beginning, the machine is playing incredibly stupidly. It's completely random. But what happens? If the machine loses, it's less likely to go follow that decision tree again because there's fewer of that color bead. If the machine wins, I go into my little handy-dandy box and refill the bead I took out plus 2 more. So I put 3 more beads in there so it becomes more likely to do the good move. And a draw in tic-tac-toe is also a great answer. So what happens there is we put the bead we took out and 1 more bead back in. So we run out of the bad moves, we reinforce the good moves, and he has graphs in his original paper that I didn't reproduce here that show that after about 210 games, the Matchboxes are playing a perfect game of tic-tac-toe without ever having programmed it. So I love showing that, and my audience is usually able to understand my explanation. So moving into a more modern age, I think that may be actually a picture of my replica Kenbeck and not the real one, but 1971 is the Kenbeck Computer, and the inventor, the designer of it, played tic-tac-toe. It only had 256 bytes, so he was working hard. It played the game, apparently. I have a replica. Maybe I'll try it one day. But he couldn't tell whether the machine won or lost. If you go over to our booth, Ryan from my team, the man is crazy. He loaded up our 32, our 34, and our 36 in our museum truck and drove it all the way out here. You can play various versions of tic-tac-toe. We just set up a new room with the IBM PC, its predecessors, and its successors, and a bunch of them have tic-tac-toe on them. So here's a listing of the programs. Here we are at the System Source Computer Museum with the IBM 5110 Model 3. Ryan has loaded an 8-inch floppy disk with a bunch of games on it. And now he's going to type L0 load, and then the catalog number, which was 12, from drive 8D, 80. Now he's going to load the tic-tac-toe game. And maybe you heard the wonderful sound, and then he's going to hit run. This is the game of tic-tac-toe. Do I understand it? Yes. You want to move? Go ahead. So move to the center. Not the fastest. And the IBM moved over on the side, so Ron, you should be able to win this one. So let's try 1-1. Row 1, column 1. And IBM properly blocked, but you're going to win if you go at 1-3.
Here we are at this.
So I think I'm a pretty smart guy, but this is where I lose it. Starting in 2006, various professors and other folks have been writing and implementing quantum tic-tac-toe. So it looks sort of like a regular tic-tac-toe board, but you put down two marks that are in superposition with one another, and there are implementations on the web. I have the game loaded on my Android phone. There's also an iPhone version of it. Is anybody here able to explain how it works? I guess that'll be the artifact of the future as the next generation learns quantum programming, but it's not me. And then lastly, I started our business. We started as a Computerland franchise. Computerland grew out of IMSI. When IMSI went bankrupt after the Apple II, the Commodore PET, and the Radio Shack came out, they took, IMSI went out of business, and Millard and Faber pivoted, started the Computerland franchise. I began working at the Computerland franchise. I chased a girl to Washington the summer of 1980, worked there, said this is fun, called my business partner, said let's do it. So my first day on the job was repairing an IMSI. My second day on the job was repairing a super brain. So that's how I got my start. And of course, here in fiction, there's the famous scene of tic-tac-toe from War Games.
No, we already tried that. Put it up. Yes, put it up.
So I'm sure most of you have seen the film, but here's a reminder.
It's not on the list.
It's not on the list.
Go ahead. It's going to be in there somewhere.
You're in. Order to the song.
No, no. No, just got back the phone.
Put X in the center square.
Six up. There's no way you can win that game. I know that. It doesn't. It hasn't worked. Is there anybody that can play itself?
Yes, now play a Sarah.
So anyway, at least in fiction, Tic Tac Toe kept us from thermonuclear war. So that's all I have, unless anyone has any questions, comments. One thing, if anybody has a picture, I've been looking all over the place for a picture of the Tic Tac Toe machine at the New York World's Fair. There are lots of pictures of the World's Fair, of the Bell Pavilion, a lot of the other artifacts that I also happen to have in the museum of some of the early picture phones and whatnot, but I've been unable to find a picture of this or exactly what it was. I would love to find it because I have the picture in my mind from 1964, but I was only 7 years old, so I don't know how accurate it is. Well, thank you.